Putting us. হ্যালো এভরিওয়ান, আসসালামু আলাইকুম। আশা করছি সবাই খুব ভালো আছেন। শুরু করছি জাভা ইউজার গ্রুপের পক্ষ থেকে আরো একটি অনলাইন সেশন। প্রতিবারের মতো আমরা আশা করছি যে এটিও খুব ইন্টারেক্টিভ একটি সেশন হবে। আপনাদের অংশগ্রহণ এবং প্রশ্নের উপর বিশেষ গুরুত্ব থাকবে। তাই আপনারা চেষ্টা করবেন যতটুকু সম্ভব যত বেশি ইন্টারেক্টিভ করা যায় আপনারা প্রশ্ন করবেন আমাদের এই যে মাধ্যমে আপনারা শুনছেন ফেসবুকে কিংবা হচ্ছে ইউটিউবে কমেন্ট সেকশনে গিয়ে আপনারা হয়তো কমেন্ট করতে পারবেন। তো আপনারা শুরুতে অনেকেই দেখছি যে আপনারা ইতিমধ্যে জয়েন করে ফেলেছেন। আপনারা কে কোথা থেকে জয়েন করছেন আমাদেরকে জানিয়ে দিন। তাহলে আমরা সেটা নিয়ে আলোচনা করতে পারবো এবং এবং ইউনো আপনাদের আরেকটি বিষয় যেটা আমি অনুরোধ করব শুরুতে, আপনি আপনার বন্ধু বান্ধব এবং কলিগদেরকে জানিয়ে দিন যে তারা অংশগ্রহণ করতে পারে এবং সেশনটি আরো অনেক বেশি ইন্টারেক্টিভ হয় আর কি। সো আজকের সেশনটি একটি খুবই গুরুত্বপূর্ণ একটি সেশন। বিষয়বস্তু হচ্ছে গুড কোড, ব্যাড কোড অ্যান্ড ভালনারেবল কোড। আপনারা যারা ইতিমধ্যে এই সেশনে জয়েন করেছেন, আমি ধরে নিচ্ছি যে সবাই প্রিটি মাচ অল্প বিস্তর কোড লিখে থাকি। তো তবে কোড যাচ্ছে মানে যেভাবে খুশি সেভাবে লেখা যায় না, এটা মোটামুটি আমরা সবাই জানি, তাই না? গুছিয়ে সুন্দরভাবে কোড লিখতে হয়। এমন ভাবে কোড লিখতে হয় যাতে আমাদের এই কোডটা একটা লম্বা সময় ধরে মেনটেন করা যায়। তাই কোনটি ভালো কোড এবং কোনটি খারাপ কোড এই বিষয়টি জানা খুবই জরুরি। এর সঙ্গে আরো একটি বিষয় আছে, সেটি হলো ভালনারেবল কোড। এই বিষয় নিয়ে আলোচনা করতে আমাদের সঙ্গে যুক্ত হয়েছেন মনোয়ার হাফিজ। মনোয়ার ভাই, হি ইজ দ্য ফাউন্ডার অ্যান্ড সিইও অফ ওপেন ফ্যাক্টরি, অ্যান অ্যাপ্লিকেশন সিকিউরিটি কোম্পানি। সো আমি আর বেশি কিছু বলবো না, লেট মি pull him, and without any further ado, Manohar bhai, welcome to our session. Floor is yours.
Sure. So I actually plan to have the talk in English. I hope that's not a problem because I have some other colleagues from US joining me here. So that's why the talk will be in English. But when we go to the question and answer, we can get the question and answer in Bengali. I actually originally planned to, so I live in the US, and originally this talk was planned to be given from the US. While I would be in US, but I mean the circumstances are such that I happen to be in Bangladesh right now. So yeah, I mean we don't know. Like when the talk was planned, I was supposed to be in another like half a way around the world, but right now I'm here. So I mean that's just an interesting anecdote to start with. But let me start. Basically, I have a presentation that's about 35-40 minutes, and then I'll take question and answer. But if you have any question and answer, feel free to interrupt either Bozlur or Mushfiq, who's one of our co-founders. They will just interrupt me and ask questions, and I welcome to have an interactive session as we go ahead. I'm Munawar Hafiz, as Bozlur mentioned, and I am a connoisseur of good code. And good code, I compare good code as something that is elegant, a beauty to behold and appreciate, not something that is dilapidated and unplanned and basically hard to maintain and also hard to extend. So from that perspective, I compare coding with gardening. There's very good analogies between these two activities, and there are three key ideas in gardening that actually also resonate back to coding. So like coding, gardening starts with a good plan. You need good supplies in order to do a good gardening. And you also need to, it's a tedious job, you need to do continuous nurturing and maintenance. Similarly, a code starts with a plan and a good architecture. But there is, the architecture is, so I posit that Basically, every code, even the failing ones, every software starts with a very good plan. It's there is a very well-known anecdote that's in the army that says that every army has a battle plan until the first contact is made with the enemy. So when somebody starts a project, typically there is a good plan that's behind it. But as you go ahead, things started to fall apart. Things started to go out of plan, and at a point, the code that you're developing, it actually outgrows the original architecture, or the architecture doesn't keep up. Both of them do not keep up, and as a start, when that bifurcation starts to appear, at that particular point, the code degenerates. So here's an example of actually an extreme level of degeneration. This is an architectural style in Minecraft. It's a Japanese style called Ihu Kenchiku, or basically illegal Minecraft architecture, because here you are juxtaposing a Japanese pagoda style architecture with a German architecture with turrets, as well as US architecture with skyscrapers. And clearly that when you like put multiple design philosophies together and try to make something out of it, typically nothing comes out of it. So that's part of the plan that typically people start with, but at some point things fall apart. Next, the second aspect that I was talking about was about good supply. And as Java coders, we can actually pat our back that we have already made a good decision in our life. We have chosen a language, one ring to rule them all. It's Java, which is like in the past 25 years have been dominating in the enterprise software sector. So just choosing that particular language actually does a lot of good, because many different languages have parts or basically not parts, actually quirks within itself that contribute to actually when you're writing code in it, it causes a lot of degeneration. So here is an interesting idea. Here is a program, believe it or not. It's basically an obfuscated program written in a particular language. I would open the floor and ask for any guess of whether people know what this language is or any idea. And feel free to type it up. I'll wait for about 15 seconds. I guess people are overwhelmed by this. So this program is Perl, and believe it or not, this is only a 2048 line word program, but this is actually a graphical. This generates a graphical user interface. It's a Perl TK program that creates a Frogger. Frogger is a famous game that goes back in the video game like Parlance. And so this particular program generates a bare bones version of that Frogger. This program won the obfuscated Perl programming contest in 2010. Obfuscated Perl programming contest
অলরাইট গাইস, সাময়িক ত্রুটির জন্য দুঃখিত। সম্ভবত ইন্টারনেট, the internet is not properly currently working, so we'll get back soon. Meanwhile, if you have any questions and কে কোথা থেকে জয়েন করছেন আমাদেরকে জানান। আহ, আমরা ডিসকাশন কন্টিনিউ করতে পারি। যেমন দি রেজিওনাল হুদা, আপনি আপনি বলেছেন যে স্লাইডস আর নট চেঞ্জিং। উনার যেটা হয়েছে যে দি ইন্টারনেট ওয়েন্ট ডাউন ফর সাম reason, probably I don't know, but we'll get back soon, hopefully. আমি যেটা করতে পারি সেটা হচ্ছে যে এর মধ্যে আমরা ডিসকাশন চালিয়ে যেতে পারি। সো কে কোথা থেকে জয়েন করছেন, আমাদের অনুষ্ঠান দেখছেন, কোনো স্পেসিফিক প্রশ্ন থাকলে সেগুলো আমাদেরকে করতে পারেন। আমি চেষ্টা করব যে as soon as he gets back we'll continue the discussion as we planned. সো একটা প্রশ্ন আমি দেখতে পাচ্ছি, মোহাম্মদ মেহেদি হাসান। The প্রশ্নটা হচ্ছে যে I have been learning Java since last December. Some of my friends tell me that Java is going to be finished. So questions is that Java is really being finished? এটা সহজ উত্তর হচ্ছে না, এবং জাভা মোটেই হারিয়ে যাওয়ার মতো কোনো প্রোগ্রামিং ল্যাঙ্গুয়েজ না। এটা থাকবে, আরো আপনি নিশ্চিন্ত ভাবে মনে প্রোগ্রামিং শিখতে থাকুন। আশা করি নেক্সট আরো 25 ইয়ার্স এই প্রোগ্রামিং ল্যাঙ্গুয়েজ চলবে, থাকবে। এটার কারণ হচ্ছে যে এখন মিলিয়নস অফ লাইন অফ কোড যেটা জাভা দিয়ে অলরেডি লেখা হয়ে গেছে, তারা হচ্ছে তাদেরকে তো মেনটেন করতে হবে, এবং আরো অসংখ্য নতুন প্রজেক্ট জাভাতে লেখা হচ্ছে এবং লেখা হবে। এর অনেকগুলো কারণ আছে। এই বিষয়ে আমি অলরেডি একটা সেশন নিয়েছিলাম জাভা ইউজার গ্রুপের পক্ষ থেকে। আমি চেষ্টা করবো এটি আপনাদের সঙ্গে আবার শেয়ার করার জন্য। সংক্ষিপ্ত কথা হচ্ছে যে না, মানে এটা নিয়ে ভয় পাওয়ার কোনো কারণ নেই, বিচলিত হওয়ার কোনো কারণ নেই। জাভা উইল বি দেয়ার ফর লং long time. So don't worry. Keep learning. You don't have to worry about that. So আমরা দেখতে পাচ্ছি যে রেজানুল হুদা জয়েন করেছেন ঢাকা থেকে, খান আব্দুল্লাহ জয়েন করেছেন ঢাকা থেকে। আর কে কে কোথা থেকে জয়েন করছেন আমাদেরকে জানিয়ে দিন, তাহলে আমরা হয়তো আপনাদের আমরা দি সেশনটা আমরা আর একটু ইন্টারেক্টিভ করতে পারবো। Meanwhile, we are trying to reach our speaker. Hopefully he will be able to join soon. আমি দেখছি মিজানুর রহমান নারায়ণগঞ্জ থেকে জয়েন করেছেন, জাহিদ হাসান ঢাকা থেকে জয়েন করেছেন, তারপরে হচ্ছে মোহাম্মদ রাকিব, থ্যাংক ইউ ফর জয়নিং। Hopefully we're going to get back in our session quickly. আচ্ছা, আমি কিছু প্রশ্ন নিয়ে নিই। মিনওয়াইল প্রশ্ন হচ্ছে যে একটা প্রশ্ন হচ্ছে এরকম যে আমি পিএইচপি ডেভেলপার, আপনি জাভাতে সুইচ করতে চান, প্লিজ গিভ মি সাম ওয়েলকাম। অবভিয়াসলি আপনি জাভাতে সুইচ করাটা খুব আমি অবশ্যই আপনাকে সুস্বাগতম জানাবো। তবে কিভাবে শুরু করবেন এটা একটু বলে নিই যে অন্যান্য ল্যাঙ্গুয়েজ যেমন আমি নাম বলতে যাচ্ছি না, যেমন কিছু কিছু ল্যাঙ্গুয়েজ আছে যাদের লার্নিং কার্ভটা খুব কুইক, খুব দ্রুত শেখা যায়। তো জাভার ক্ষেত্রে হচ্ছে লার্নিং কার্ভটা খুব দ্রুত, একটু স্টিফ, আপনাকে বেশ সময় দিতে হবে। আপনার একটু শুরুর দিকে মনে হতে পারে যে অনেক কিছু শিখতে হচ্ছে এবং অনেক সময় লাগছে, তাই না? এটা একটু সমস্যা। বাট একটু যদি সময় ধৈর্য নিয়ে দেন তাহলে দেখা যাবে যে আপনার এই সবকিছু আয়ত্তে চলে আসছে, তাই না? একটা ভালো জিনিস শিখতে তো সময় লাগবেই, এটাই স্বাভাবিক। সো অনেকেই যেটা হয় যে শুরুতে কিছুদিন সময় দেওয়ার পরে ফ্রাস্ট্রেটেড হয়ে যায় যে হ্যাঁ আমি আর পারতেছি না, এটা অনেক সময় লাগতেছে। সো এই ফ্রাস্ট্রেশনটা সবারই থাকে। আমি বলবো যে একটু যদি লেগে থাকেন যে কোনো জিনিসই, লার্নিং টেক্স টাইম, তাই না? আমরা তো খুব চট করে কোনো কিছু শিখতে পারি না, এবং দ্যাটস ওয়াই আমরা যখন কোনো কিছু একটু পরিশ্রম করে অ্যাচিভ করি এবং তার ফলাফলটা ভালো হয়, তাই না? তো এই জন্য হচ্ছে আমি বলবো যে আপনি যে কোনো একটা বই নিয়ে শুরু করুন। একটা বই, জাভা প্রোগ্রামিং এর উপর প্রচুর বই লেখা আছে, যে কোনো একটা বই নিয়ে শুরু করুন এবং আপনি ট্রাই টু স্টিক টু ফ্রম দ্য ফার্স্ট পেজ টু লাস্ট পেজ। পুরোটা একবার পড়া হয়ে গেলে এবং এর ভিতরে যে এক্সারসাইজ গুলো থাকবে খুব ভালোভাবে যদি করেন, তারপরে দেখা যাবে যে একটা সময় আপনার আয়ত্তে আসছে। সো আপনি একটা বই যদি পড়তে শুরু করেন, প্রথমে দেখবেন যে কিছু কিছু জিনিস খুব ইজি মনে হবে, খুব কুইকলি করতে পারবেন। আবার কিছু কিছু জিনিস মনে হবে যে খুব কঠিন, বুঝতেছেন না। আমি বলবো যে শুরুতে সেগুলোকে স্কিপ করে যেতে পারেন, পুরোটা বই শেষ হলে তারপরে আবার সেকেন্ড টাইম এসে যে বিষয়গুলো স্কিপ করে গেছিলেন ফার্স্ট টাইম, সেগুলোকে আবার হচ্ছে ট্রাই করুন। তাহলে তখন দেখা যাবে যে জিনিসগুলো খুব ইজিয়ার হবে। এবং আরেকটা জিনিস হচ্ছে যে রেগুলারিটি মেনটেন করা, তাই না? একটা জিনিস লার্ন করতে গেলে একটু সময় দিতে হয়। এবং লেটস সে আমি হচ্ছে আজকে 5 ঘন্টা টানা কাজ করলাম, নেক্সট 2 উইকস আমি আর কোনো কাজ করলাম না, তাহলে একটা সমস্যা তৈরি হবে আর কি। হ্যাঁ, তো এই জন্য আপনি টানা 5 ঘন্টা না করে আপনি যেটা করতে পারেন, 1 ঘন্টা 1 ঘন্টা করে প্রতিদিন সময় দেন, অথবা আরো কম। শুরুতে আপনি হচ্ছে আহ, শুরুতে হচ্ছে আহ, আপনি 25 মিনিট কিংবা আধা আধা ঘন্টা করে সময় দিন, কিন্তু রেগুলারিটি ইজ এক্সট্রিমলি ইম্পর্টেন্ট। অলরাইট, অনেকে আরো আমাদের সঙ্গে আরো অনেকেই জয়েন করেছেন। সিলেট থেকে জয়েন করেছেন আব্দুল্লাহ আল মাহি, আজিজুল হাকিম ঢাকা থেকে, জাহিদ হাসান ঢাকা থেকে, ওকে। সো ধামরাই থেকে একজন জয়েন করেছেন। Yeah, that's good. That's really good. Keep practicing. Practice basically আমাদেরকে ইমপ্রুভ করে, তাই না? ওকে, সো আমাদের সঙ্গে জয়েন করেছেন হচ্ছে ওকে। সো জাভা, হাউ কম্পিটিটিভ? ডেফিনেটলি আপনি কম্পিটিটিভ প্রোগ্রাম জাভা দিয়েও করতে পারেন। তো নর্মালি ট্রেন্ড হচ্ছে অনেকে সি সি প্লাস প্লাস দিয়ে করে, বাট জাভা দিয়েও করা যায় আর কি। হ্যাঁ, সো আই ডোন্ট থিঙ্ক ইটস এ প্রবলেম। ইউ ক্যান ডু কম্পিটিটিভ প্রোগ্রামিং উইথ জাভা অ্যাজ ওয়েল। ওকে, সো আমি হচ্ছে ইউআরএলটা হচ্ছে আমাদের ফেসবুক পেজে দেওয়া আছে, আমাদের ফেসবুক গ্রুপে দেওয়া আছে। ইউ ক্যান জয়েন ফ্রম দেয়ার, অথবা আমার পেজেও দেওয়া আছে। সো সরি, আমার প্রোফাইলে দেওয়া আছে, সো সেখান থেকে আপনি জয়েন করতে পারেন। ঠিক আছে। সো আমি লিঙ্কটা আমি আবার কমেন্টে দিয়ে দিচ্ছি। আপনারা যদি একটু কাইন্ডলি শেয়ার করবেন সবার সঙ্গে, তাহলে যেটা হবে যে আম, সবাই জয়েন করতে পারবে, তাই না? ওকে, সো আমি আরেকটা কোশ্চেন নিয়ে নিচ্ছি। সেটা হচ্ছে যে প্রশ্নটা হচ্ছে জাভা ইকোসিস্টেম নিয়ে বলবেন নাকি ভাইয়া? ওয়েব ডেভেলপমেন্ট মাইক্রোসার্ভিসের জন্য কি ধরনের ফ্রেমওয়ার্ক অ্যাভেলেবল? ওয়েল, ওকে, জাভা আসলে একটা বড় ইকোসিস্টেম। খুব অল্প কথায় খুব সংক্ষেপে বলা ডিফিকাল্ট, তারপর আমি চেষ্টা করছি যে ওয়েব ডেভেলপমেন্ট বা মাইক্রো সার্ভিসের জন্য ইউজুয়ালি আমরা স্প্রিং ব্যবহার করে থাকি। ইটস মোর অফ এ ডমিনেটিং ফ্রেমওয়ার্ক। আপনি যদি কুইকলি শিখতে চান তাহলে হচ্ছে আই উড রেকমেন্ড ইউ টু স্টার্ট লার্নিং স্প্রিং বুট। দ্যাটস মানে প্রিটি মাচ ওয়েব ডেভেলপমেন্ট বলেন, মাইক্রো সার্ভিস বলেন, হ্যাঁ, স্প্রিং ফ্রেমওয়ার্ক মোটামুটি ডমিনেটিং। এছাড়াও আরো কিছু ফ্রেমওয়ার্ক আছে, সেগুলো লিস্ট অফ ফ্রেমওয়ার্ক আছে। আপনি যদি জাভা ফ্রেমওয়ার্ক দিয়ে গুগল করেন দেখবেন যে এই লম্বা লিস্ট চলে আসবে। আমি রিকমেন্ড করবো পার্সোনালি গো হেড উইথ স্প্রিং অ্যান্ড স্প্রিং বুট। সো এটা মোটামুটি ডমিনেটিং ইন দি ইন্ডাস্ট্রি। অলরাইট, okay, we are still trying to reach our speaker. Hopefully we'll be able to reach him soon. Meanwhile, ওকে, আমি হচ্ছে ইভেন্টের ওয়ার্ল্ডটা চেঞ্জ করে দিচ্ছি, ডোন্ট ওয়ারি, লেট মি ট্রাই দ্যাট। ওকে, সো যেটা হয়েছে যে আমাদের স্পিকারের পাওয়ার আউটেজ হয়ে গেছে, সো দ্যাটস ইট, দ্যাটস ওয়াই ইন্টারনেট ফেল করেছে। তো উনি হয়তো চেষ্টা করবেন মোবাইল থেকে জয়েন করার জন্য, হোপফুলি হি উইল বি এবল টু জয়েন সোন। Meanwhile we can keep taking your questions and continue the discussion. So ask me question anything related to Java, I'll be able to answer those questions. Okay, so আমি যেটা করব ইভেন্টে আপনাদের okay, so yeah, he's trying to, our speaker is trying to rejoin, hopefully he will be able to join soon. Mm, all right, let's see. Sorry about the again, we are extremely sorry about this inconvenience. It happens বাংলাদেশে যেটা হয় যে মাঝে মাঝে এই ধরনের প্রবলেম হয়, we are used to with all of those things, hopefully we'll be able to overcome soon. Meanwhile, we're still trying to reach our speaker, hopefully we'll be able to reach him soon. If you have any other questions related to Java specifically, or you can definitely ask about the specific topic that I'll keep those questions to our speaker, for our speaker. Sure. So yeah, let me take some questions. Why not? It's so default method যে কারণে এসেছে সেটা হচ্ছে যে আমাদের, আচ্ছা এটা নিয়ে আমরা আসলে আজকের বেশি যেহেতু টপিক না, so I would probably not discuss further about this, but it's definitely not a problem. Why should Well, why should I choose Java instead of .NET? That's a good question. I would এটা আসলে মূলত চয়েসের একটা ব্যাপার, এক একজন এক এক ধরনের টেকনোলজি চয়েস করে, সো দ্যাটস দেয়ার। অ্যাপার্ট ফ্রম দ্যাট, জাভা ডেফিনেটলি প্ল্যাটফর্ম ইন্ডিপেন্ডেন্ট, যদিও ডট নেট এখনো প্ল্যাটফর্ম ইন্ডিপেন্ডেন্ট। আই ডোন্ট নো, ইটস বিন সেইং দ্যাট ইটস প্ল্যাটফর্ম ইন্ডিপেন্ডেন্ট, সো আমি খুব বেশি জানি না ডট নেটের উপর, বাট জাভার এই যে একটা ইকোসিস্টেম এবং এটার যে কারণে আমি পছন্দ করি সেটা হচ্ছে যে ইট হ্যাজ এ এন্টার ইকোসিস্টেম, এটাতে অনেক কিছু প্রবলেম যেটাতে অলরেডি সলভ হয়ে গেছে। সো আমি যখন কোনো একটা প্রবলেম নিয়ে ডিল করতে চাই, দেখি যে মোস্ট অফ দি প্রবলেমস আর অলরেডি সলভড ইন দি সিস্টেমস। এছাড়া অনেকগুলো বড় বড় কোম্পানি আর ব্যাকড বাই জাভা, রাইট? ওরাকল তো আছেই, ইভেন মাইক্রোসফট ইটসেলফ নাওয়াডেজ কন্ট্রিবিউটিং টু দি জাভা। আপনি যদি দেখেন যে জাভার যারা কন্ট্রিবিউটর, এর মধ্যে মাইক্রোসফট একটা বড় 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 কন্ট্রিবিউটর আর কি। এছাড়া আরো অনেক কম্পিউটার স্ট্যাপ, মাইক্রোসফট, তারপরে রেড হ্যাট যদিও কিনে নিয়েছে, তারপরে রেড হ্যাট ইটসেলফ হিউজ কন্ট্রিবিউটর অফ জাভা। এছাড়া আরো বড় বড় লম্বা লিস্ট অফ কোম্পানি আছে যারা জায়ান্ট কোম্পানি, যারা হচ্ছে জাভা কন্ট্রিবিউট করছে। সো জাভা যদিও ওরাকল এই ট্রেডমার্ক, বাট জাভাকে কিন্তু ওরাকল মানে ওন করে না, তাই না? ইটস ওন বাই কমিউনিটি, সো কমিউনিটির একটা বড় অংশ। এই কারণে আমি মনে করব যে the community is very vibrant and different from any other communities. কম্পেয়ার করাটা ডিফিকাল্ট, বাট আই লাভ দিস কমিউনিটি অ্যান্ড এটার পেছনের যে ব্যাক দি কমিউনিটির সাইজটা অনেক বড়। দে সে প্রায় 12 মিলিয়ন জাভা ডেভেলপার আউট দেয়ার, তাই না? সো ইটস এ হিউজ কমিউনিটি। সো ইফ ইউ হ্যাভ ফেস এনি প্রবলেম, কেউ না কেউ হয়তো আপনাকে এই প্রবলেমটা সলভ আপনাকে হেল্প করতে পারে। So I guess that's your answer, short answer, but we can definitely have a different session with আমি একটা অনলাইন একটা সেশন নিয়েছিলাম, 1 ঘন্টার মতো একটা লম্বা টপিক, যেখানে হচ্ছে আমি বলেছিলাম যে এই কারণে আমি জাভা পছন্দ করি। আল শেয়ার দ্যাট। আমাদের জাভা ইউজার গ্রুপের যে ইউটিউব চ্যানেল আছে, সেখানে গেলে আপনি হয়তো দেখতে পাবেন যে টপিকের টাইটেল ছিল যে 20 রিজন হোয়াই I love Java or why I like Java, something like that. I don't remember the exact title, but you can go there and find out the reasoning why I personally like Java. So I hope যে সেটা আপনাদের জন্য ইউজফুল হবে। অলরাইট, সো আরো কিছু প্রশ্ন চলে এসেছে, দেখা যাক, আমরা প্রশ্নগুলো নেওয়ার চেষ্টা করি। And meanwhile, I'm still trying to reach our speaker. Hopefully, he will be able to join soon. Okay. Okay, so we have hey, can you hear me? I think your audio is not working. Can you see if your audio and your webcam is working? এই প্রশ্নটা বেশ কমন প্রশ্ন বিটুইন ওপেন জেডিকে এন্ড ওরাকল জেডিকে। সো যেটা হচ্ছে যে দুইটার আসলে এজ এ ডেভেলপার পয়েন্ট অফ ভিউ থেকে, হ্যাঁ, দুইটার মধ্যে কোনো ডিফারেন্স নাই। বাইনারি, দুইটার বাইনারি আসলে সেম। দুইটাই আসলে ওপেন জেডিকে যেটা ওপেন জেডিকের উপরে বেস করে হচ্ছে, মানে সোর্স কোডের দিক থেকে কোনো ডিফারেন্স নাই, জাস্ট বিল্ডটা ডিফারেন্ট, রাইট? সো যেটা হয় যে ওপেন জেডিকে যদি আমি ইউজ করি, তাহলে যেটা হবে যে আমি কি বলে, আমাকে ওই আপডেট করে নিতে হবে রেগুলার বেসিসে। আর ওরাকল যদি হচ্ছে কোনো একটা প্রবলেম হয় জেডিকের মধ্যে, ধরেন কোনো একটা সিকিউরিটি ইস্যু, ভালনারেবিলিটি আসে, সো ওপেন জেডিকে ইউজ করলে সেটা রেসপন্সিবিলিটি আমার। আমি হচ্ছে পুল রিকোয়েস্ট গুলো নিয়ে বা আপডেটেড থাকতে হবে। অনেকেই বিল গুলো শেয়ার করে। সো সেই দিক থেকে আপনি হচ্ছে ইউনো আপনাকে নিজে থেকে আপডেটেড করে নিতে হবে। আর ওরাকল যেদিকে যদি ইউজ করেন, ইফ ইউ পে দেম, দে উইল ডু অন বিহাফ ইউর সেলফ। সো ওইটা হচ্ছে বেনিফিট আর কি। ওরাকল ওরাকল যেদিকে যদি ইউজ করেন এবং প্রোডাকশন ইউজ করেন, ইউ হ্যাভ টু পে দেম অ্যান্ড দে উইল টেক কেয়ার অফ দেয়ার বিল্ড অ্যান্ড আদার থিংস. And if you use OpenJDK, it's your responsibility to get updated version, and that's the only caveat. Other than everything is pretty much same. All right, we have a speaker on behalf of Monwer. His name is Charlie. I guess I'm not sure if I pronounced it correctly. He is the CEO of Open Factory. He is going to talk on behalf of our speaker, since he is we are not able to connect him.
Do you have my audio?
Yes, I have your audio now.
So, hey, we got Munawar back! Hooray!
Yeah, there was some
finally.
issue about the network. I don't know. I mean, yeah, sorry about that. So I actually went through a little bit of the presentation without realizing that I was not you were not able to hear me.
All right, no worries. So we got you back. That's a wonderful news. All right, let's get back from where we left. অডিয়েন্সদের কাছে যে প্রশ্ন করবো, আপনারা কি স্লাইডটা দেখতে পাচ্ছেন কিনা একটু আমাদেরকে যদি কমেন্টে জানিয়ে দিন, তাহলে আমাদের জন্য সুবিধা হবে আর কি।
Sorry, I was not able to hear you completely. Can you repeat?
So what I said is, let's get started with this topic from where we left. Are you still are you able to hear?
Where we left, Munawar, is you had just been talking about obfuscated code and I think making a point about how elegant code shouldn't be so obscure.
I guess you can start from there. I don't know the number of slides, but yeah, you can start from there. I'm not sure he's still able to hear. What I can do is I can share the slides from my end, and Charlie, you can continue. How would that? I think your audio is perfectly fine.
Well, I can speak to some of the issues. I do not have the expertise that Munawar has in terms of, and certainly his professorial style of being able to teach and communicate it. I can certainly address some of the key points. And I can also speak to Munawar's expertise as we talk about this, because I think a lot of the folks on the call may not know Munawar's background in terms of how much work that he has done in this area and the care and the effort that he's put into developing various technologies. So let's see where we can go with this. And if
Sure.
Munawar, are you controlling the slides, or is Munawar controlling the slides?
I am doing.
Okay.
Because yeah, let me know where to go.
Well, why don't you skip through the first few? I certainly don't want to repeat where he has been. And if he gets his audio back, perhaps if he kills his video, that might help his bandwidth. So,
all right. Let me know from where I should.
Just keep going. Just keep going through the samples of obfuscated code.
Okay. How would here?
Yeah. There, I see Munawar's video, so hopefully his audio is coming soon. Skip again, one more slide.
Yeah. How would that?
Well, yeah. So where I think he wants to go with the conversation here, and I've always enjoyed his metaphor of gardening. In terms of, I mean, just myself, I've been working with Java since Java 1.0 from a long time ago. So I've watched it. I've watched its evolution and what has happened to it over the last 20, 25 years. So one of the things that he's focusing on is the idea of being able to not only write elegant code or write good code to begin with, but use tools, as you would in a garden, use tools to help improve the quality of the code for removing, vulnerabilities, but also for performance. Okay, and what that often means is refactoring. And it's the refactoring that actually got me connected with Munawar a number of years ago when I was learning about his work in this area. My understanding of refactoring was, as he talks about, no good plan survives first contact with the enemy. What happens is, as code evolves, it typically degrades. And so you often want to refactor to simplify. And can be a tedious process, and I have found in my own experience as a manager of Java development programs that it's often hard to find the effort, the energy, or even persuade management to do refactoring. So having tools to do refactoring, to improve the code, is valuable, but it's a difficult problem. So why don't you skip over to the next slide, because I actually haven't seen the slides yet, because this is a new talk that Munawar has put together. So yeah, move forward again. And that's what I was talking about in terms of what happens. Gee, that Munawar has aged quite a bit in this photo here. So yeah, what happens is as software evolves, it changes and it usually degrades. You know, if you know your physics and laws of entropy, right? Nature pushes us towards chaos and lack of order. So yes, what happens over time is it moves, and often, I like his phrase of ignorant surgery, often attempts to refactor or clean up code can make it worse, especially if you don't understand the meaning of the program. So why don't we move forward a slide? And in fact, I've always liked this image because as we evolve and try to move the software forward, programmers introduce bugs. And in this case here, they're chasing them, all right? And often we have found, in fact, I think the next slide may have some information on this. Click that forward. Oh, the other direction. Oh, the wrong way. There we go. That's what I thought. That, in fact, bugs get introduced and problems in the code get introduced faster than we can take them out, frankly. There's a database that tracks vulnerabilities, and these are, you know, bugs can come in all kinds of flavors. There's, of course, you know, logic errors which occur, but a huge fraction of the bugs that get introduced in the code, and even Java, which is, as Munawar was saying, is a good language of choice because of the concepts in it to help prevent common programming problems. It still is susceptible to programming errors where the developer themselves writes a piece of code that they think is good, but it's subject to exposure to attacks from security hackers. And in the US, there's a thing called the National Vulnerability Database, which is actually managed by the government. And over 100 of these kinds of vulnerabilities are reported in major programs on a weekly basis. So those bugs get introduced. It takes a long time to fix them, because often it takes a long time to detect them. In fact, in some cases, some of these problems can remain in code for a very long periods of time, over a year, in fact, in some cases. And studies have shown that, you know, for every million lines of code, and we're talking of even in Java code here, even after testing, dynamic testing, logical testing, automated testing, still in every million lines of code, there's 15,000 bugs that get shipped. And that means that those are holes that can be, and often those are security holes that can be attacked, or reliability problems that can cause failures of the software. In another presentation that Munawar and I have done in years past, we've shown a video of some spectacular failures, such as a rocket blowing up or a power failure in a huge part of the power grid that were caused by simple programming errors, like a software overflow, for example. So this begs the question. And this has actually been the core of Munawar's research when he started his PhD work a number of years ago at University of Illinois. And that was, gee, since refactoring code is a good idea in terms of cleaning it up and making it more readable and helping resist code degradation, why can't we apply the ideas of refactoring to detect and even correct these kinds of vulnerabilities? So let's look at the next slide and surprise me, and I'll see what the next slide is. Yeah, so what about tools to help us do that? Next slide, please. Well, so one of the things that this slide refers to when we talk about, you know, why not try to find and fix these problems? Well, the first part of the problem is, how do we find them? So the finding problems in code, Java code, and in fact, all kinds of programming languages have been around for quite some time, probably 20 years and longer. And if you look at this slide, we were trying to capture kind of what's the lay of the current land of finding problems in code. And there are many companies that have been around for a long time that detect. And I think some of the slides that we have going forward will talk a little bit about the techniques used in code detection. Those of you who are familiar a little bit with compilers probably know that there are various steps in analyzing a program. Well, how people detect is they take a program, they basically precompile it or break it into basic components, and then they build a mathematical model of what the program is, a static model, and then they analyze that. And so over the years, various companies have taken various approaches to that, and some detect a little bit better than others. But generally speaking, because they're working with a model of the program, and if you could imagine, you know, the nearly infinite number of paths through a program, those models have to be simplified in order to be analyzed. As a result of that simplification, they can't detect every possible programming path, and they can't detect every possible problem. So, so the way this current situation is, the detection-only companies are able to detect problems. I'll bet you some of you who are working in maybe larger enterprises where there's a lot of detection tools going on, you may recognize some of the names of these companies. You probably know that you deal with a lot of false positives. Because information is lost in the model of the program, you can only go so far in detecting all the problems. So most of these companies err, understandably, on giving you as many warnings as possible to make sure that you catch the bug. Problem with that, of course, is, you know, I have to go through all those warnings. I know when I managed engineers and did this work myself, going through the warnings can be a tedious process. And it's kind of, you know, it's great that you've got all these hints at where there may be a bug, but you have to make sure that it's a bug. And so next slide, please. I suspect that this is a build slide, because there's, whoop, well, that's not very interesting. I'm just seeing a blank slide. Oh, skip through that one. I thought skip through that one as well. And we'll hold it there for a minute. In that previous, yeah, that's okay. In that previous slide, I was mentioning that there was a quadrant. There wasn't anything up in the top right quadrant, but the top right quadrant is basically what Munawar was targeting with his research. He was saying there's all these people in the detection area, but the precision is poor, and you still have to fix them manually. So in that previous slide, he was thinking about, what if we could live in that top right quadrant instead of the bottom left quadrant, where we could analyze with more precision, and we could, not only that, once we handle that, we could refactor code to remove the problem. So I mentioned that this was the focus of his research at the University of Illinois, and you can step through the next slide because I recognize the next one as well. There's a photograph of him back in his days at Illinois and his team. I think this was also his research team when he was a professor at Auburn. And so he has done a lot of work in both the analysis and refactoring. And in fact, one of his go back to that slide, that photo, because I like that photo. This goes back, I like to see Munawar in a suit. That's why I like this photo. This was a few years ago when, in fact, one of his students, the young man on the right, actually using Munawar's research in analysis and refactoring, did a tool. I think it was in C, using it for C, and his student won the award, the ACM award, for the best paper in all of disciplines of computer science, and which was presented at the Turing Award ceremony a few years ago, and something that he was very proud of. And of course, his student was very proud of that work. So he's been working on this research for quite some time, and turning it not only into an idea, but into, you know, practical code. In other words, can you actually build tools to do that? And now that, you know, we can bring that to the next slide, which is, what if there were services that not only detected but also fixed them? That's that top right quadrant that I was talking about in that earlier slide. And so there's a number of issues in trying to do this, and do this, including the precision. So you know, when he talks about the road not taken, his thought there was, no one has tried this before. How do we do this analysis? Well, one of the things that he was, and I think he's going to talk more about this later, in terms of analyzing code, there are paths through the code. Oh, he's back.
I can take over, I think. I figured out the network problem, so let's try that. So somebody else just go through the deck. It's not going to be interactive, but I mean, at least we can make the point. As I mentioned, that as Charlie was mentioning, that the big vision that I was working on was, what if there were services that not only detected vulnerabilities but also fixed them automatically? And as a part of, as I was like embarking upon that journey and producing solutions for that, there were some general challenges that we have to face, or in general, the detection tool developers have to face, and that actually contributes to the detection tools creating a lot of false positives. And here I've identified 4 key challenges. So one of them is about the complexity of code and all the paths that a software that you can take in a software, and because you are not sure which path is actually taken in practice, you have to account for all of them when you're creating a mathematical model of software. And because of that, there's a lot of imprecision that comes in. There's a problem about there's always hidden paths in software that is not always obvious. Software is also written increasingly in a polyglot world, as in there's typically software is written in multiple programming languages these days, so that complicates the program analysis that is done in order to detect bugs. And then there's a lot of emerging problems that are also there. Next slide. So The Road Not Taken is a famous poem by Robert Frost. I think many of you may have read that or heard about it. But in program, basically, there's always branches that you can take. Next slide. And so when you are doing a static analysis on code, you are not sure which branch is taken at a particular point. So here is a very simple Java code, which may have a null pointer dereference at the bottom line where there is a bar method being called. In this particular case, this is safe because the variable j was initialized a few lines above, and the condition under which that variable was initialized is the same as the condition under which that variable is used. And therefore, there is no null pointer dereference in this case. And thankfully, all the tools that are available out there, they are able to detect these problems. There's no issue in particular case here. Next slide. If the code becomes slightly different, as in the guarding condition becomes opposite. So in a previous one, the guarding condition was I not equal to null. In this particular case, it is I equals null. Then the code becomes unsafe, as in there is a null pointer dereference that can happen here. And why is this happening? Because the variable j was initialized under a condition that is exactly opposite to the condition under which this is used. So when happens to be null, then we will come to the program point j.bar without initializing the variable j, and therefore we will get a pointer reference problem. And this is also a problem existing tools are able to detect pretty easily. So the first one able to detect, the second one the tools are able to detect. I'm getting to a third one. The tools are not able to detect. So in the next, it gets slide. Hi, can we move to the next slide?
Hello. Are you able to see the slides? Hello, which one? I'm on slide number 27 right now.
Yeah, go to 28.
Did you miss?
Did we lose his audio again? Dear. Well, I now this is getting more difficult here, but looking at the code, all right, this becomes trickier to tell whether or not this dereference of j is valid or not, all right, because k is a function of the output of the an I is a value of some method. So now, in order to be able to determine whether or not it's safe, I believe that the analysis needs to actually understand what some method does. So I'm going to wait a second here because there may be some other points that he wanted to get across here, because this is now deep into his expertise. Who knows expertise? I'm hoping his audio will come back here shortly.
All right. He in fact asked to take it over. I'm not sure.
Good.
Let's continue. Do you want to continue? He's not.
Oh, does he want me to continue?
Right. He asked you to take it over.
Okay. Well, great. Thanks, Munawar, because this is now deep into his expertise. But clearly, by just looking at this code sample, it's looking at just the context of this method. Unlike the previous example, it is just not clear whether it's safe or not, because you have to understand what the possible results are that comes back from some method. So now you have to be able to follow method references through the various classes and dig into that. And I suspect that he would say that there are some tools, detection tools, that are able to follow those paths. But as he was talking about as well, there may be paths for a variety of reasons. Not all paths can be followed. So this may or may not be safe. So let's move to the next slide, because I think that was our friends. So those of you who like to watch Cumberbatch and Bilbo, this I think is a scene from Sherlock, and I think he's referring to the detective services, and only the best detectives you need to be available to analyze the code. So let's move to the next slide. Let's see what he says here. I have no idea what he's communicating here. I think it just might be the fact that go to the next slide. I just see this as being flexibility here. Oh, I know where he's going with this idea. So what's happening is in that example where the value of I was subject to the results of a method. Okay, that means that you have to be able to probe the methods. And you have to be able to understand what those methods are doing. And those methods may be your own code, and you may have access to them. But many of those methods are also, maybe part of a library. Okay, and so as detection tools build a model of the program, sometimes there's information that about the results of a method that are embedded in a library. How do you get access to that library? Maybe that library is a jar file. It's not necessarily available as source code or whatever. So part of the problem is the map that you're making, because essentially as you're analyzing a program, you're building a model of it, there's portions of that map that are missing. They're basically blank spots. All right. And so how do you deal with those? So as you said, there are hidden paths. So next slide, please. Yeah, so exactly. So one of the ways that, in fact, I heard some of the comments and questions earlier about, for example, frameworks such as Spring and so on. There's a broad variety of frameworks, and frameworks in Java essentially mean conventions around groups of class libraries. Might be the Enterprise Edition set of class libraries, or as I mentioned, Spring or struts or other frameworks. So one of the ways to tackle this problem, and nobody does this at this point, at least in terms of the detection services that are available today, no one actually is able to incorporate knowledge of these frameworks so that you, for example, a method or a particular path might be followed because of an invocation that is effected through the use of a particular framework. And there are many of them. So one of the ways, go to the next slide, because I think I know where he's going with this here. This is code. This is demo. I'm not sure what framework this is, but I think what the intent is there's an how I think of this, and he might yell at me if his audio was available. But as I think of this is in a way, it's a non-obvious control flow. In other words, you've got a method invocation here as a result of a framework provided capability where the demo.start in fact is connected to this run method. Okay, and so in terms of this variable reference, you'll see that in the public void foo, the variable has been assigned, so it's not a null pointer. We've given it a new value. The run method is caused and is invoked as the result of a framework behavior. And as such, unless you understand what the framework is doing, that there's a connection between the start invocation and this particular run method, you don't know whether or not that reference is safe. And so one of the, in addition to the work that Munawar has done to build a more precise model of the code itself, he's also developed, and he's been working on, and at Open Refactory today, we're actually working on building ways of being able to express the behavior of a framework in a fashion that allows the analysis engines to be able to make these connections. So why don't you move to the next slide? I'm looking at this code. Sadly, I'm just seeing it for the first time. So this, I think, is another example, a framework example. I'm afraid I can't speak to it. So let's just, it's from FlowDroid, it said. So I'm not exactly sure what he's trying to where he's going with this. I apologize for that. But move me to the next slide and we'll see. I think these are further examples of framework connections that are very difficult, in fact, impossible these days with existing detection tools to find these. And this is another example. So let's skip through these because unfortunately I cannot speak to them in a coherent way. So here's a model of a data flow, or of a control flow rather. And as I'm looking at this again for the first time, I'm trying to think what the critical message is here in terms of the various paths through here. We're going to have to move through the next slide again. And this is the code that's basically implementing that flow. I'm afraid I'm going to have to skip through these examples because I've not seen them before and I can't speak to them in a good way. So what I do want to leave you with though is, well, I couldn't work through the examples and I apologize. What I wanted to make the point, because this has been a difficult problem in terms of increasing the precision of the analysis, is understanding the frameworks well enough and knowing how they work and being able to represent their behavior so we can make those connections across those framework connections. Now, the other problem, and he was talking that there's a number of challenges in doing the analysis, and another one is that he's got a mind map slide here, but I used to joke many years ago, in fact, when Java was first coming out, Java 1.0 that I mentioned I worked on, I thought, well, great, this is a good language. Hopefully the number of language proliferations will slow down. Well, that was wrong. And it seemed that over the ensuing 20, 25 years, we've gotten an even more busy world of object-oriented languages, Ruby, Python for web languages, PHP that's being used. In fact, it's gone even more prolific. Some of these languages, Erlang, for example, more oriented towards very specific types of problems. But the point is, the world that we live in as software developers is not a uniform language, okay? We don't all speak English or Bengali. There's still hundreds of languages out there, programming languages. And so one of the issues is that many of the software programs we develop cross language boundaries. And again, none of the, at least that I'm aware of, detection tools can work in this polyglot world. But this is something also that Munawar was thinking that and studying and attacking. That said, you know, if we want to build a framework which is more precise and where we can fix code, we're going to have to be able to handle this across program boundaries. One of the things I do know, I don't know if his next slides get into this in detail, but I do know that the research that he did in academia, I think this was when he was a professor at Auburn, which I found fascinating when I first met Munawar and we talked about this, because this is a difficult problem, is he actually had created, actually go back a slide, let me see if that is, Actually, he was just looking at, these are different languages, but he actually did some work. Oh, you're back. You're back again.
I can have another. I mean, this is this scenario, but anyway, let me again take over. So
sure.
Can we go to the next slide? Yeah, so this is an example that I was giving from the previous code where, or previous point, which is basically softwares are written with frameworks, and there's a lot of knowledge that the frameworks bring in, and these knowledge are typically hidden, and somehow there needs to be that knowledge that has to be brought about in order to have these detection tools perform correctly when it is analyzing code in a particular framework. So in this particular case, there is this send message, which is a callback method in this Android activity, but we do not know that who is calling that send message. That information is actually encoded in an XML file. It's not even a Java file. It's typically encoded in an XML file, and that identifies that the send message will be called when a particular button is pressed or something like that. And that's the information where a Java language and the XML language has to interact with each other in order to create a complete understanding of the program. And that needs to be there. So if a program is only analyzing Java, it would not be able to detect particular problems in this case. It gets more complicated in the next example, as shown here. This is basically like you can probably have a Spring in the Spring framework. Sometimes people use aspect-oriented programming, which is actually a more complicated paradigm. So Spring is already a complex framework with its own nuances, like Android has. And on top of it, you bring effects, like for example, you create advice, which basically means that when you are calling data access operation method, you are actually calling do access check method, poking do access check method just before calling it. So this is again a specification that is done entirely in XML. So a tool needs to be able to understand these XML, these control flow ideas or call graph idea, basically program calling ideas from the XML. So therefore, it needs to get not only understanding of the Java code, but Java and XML in both languages, and that's basically the of that the detection tools face. And because they are not able to solve that problem, create a lot of false positive. Next, we go to the final issue. That is, there's a lot of emerging problems for which the existing tools are just not capable of handling. So one such emerging problem is the energy issue in software. So for example, when we are writing an Android app, and if that Android app is, we can go to the next slide. If that Android app is consuming a lot of energy, what happens is your cell phone drain out. So essentially, your code will be also like other apps will be running slower, and overall the energy drain in your cell phone would be causing a lot of annoyance. So what I have done in this particular area is, as a test study, we looked into this ambitious problem. Can we modify program automatically in order to reduce energy consumption? So basically, can we modify a program so that it has a better battery life? I mean, imagine that's a very exciting problem. So in order to solve that particular problem, we looked into Java collection framework and how they're used. So this is basically the main classes in the Java collection framework. And next slide. So what we did was we actually measured the energy consumption of the typical operations that these collection classes do. So one of the most prominent tasks that all the collection classes do is basically they add stuff. Then the next stuff that they do is they retrieve stuff from the collection, and then they also do iteration through the collection. Those three are the primary tasks that happen on collection classes. So what we did was we looked into Java collection classes, different kinds of Java collection classes, and did energy. We performed an energy measurement. So this is basically the tool that we used. This was done when I was doing research back in Alabama, and this tool, believe it or not, was in Canada, and we were still doing. So here's what we identified. Can we go to the next slide? So here's a snippet of the result. Can we go to the next slide? Sorry, the previous slide, slide 43. Yeah, when we insert stuff in a collection class, typically, and if we insert it at the beginning, typically the linked list Java collection framework, it has the lowest energy. So if something in the graph is at a low altitude, at that means that it consumes low energy. And so a tree list, which is in Apache collections framework, if you are inserting stuff at the beginning, it consumes a lot of energy, as you see here. If you are inserting at the end, however, we found out that Trove, so from the Trove framework, the tint array list, that performs best. So it consumes the less energy. So we created multiple energy profiles like that. This is just two examples, many energy profiles like that. And eventually we created a comparison, which is shown in the next slide. So essentially what we did was we compared different kinds of collection classes against each other, and we created a heat map. So something that is green, so it consumes less energy, and something that is red, it consumes a lot of energy. So we identify that across the board, tint array list, it performs the best. Array list does not perform very well if we are performing at the beginning, but if we are doing insertion at the end, then it is actually doing a lot better. So on the other hand, linked list does it in the other way. So linked list has worse performance. So if you have a code where you are inserting at the end of the list and you are using a linked list there, if we can programmatically modify that and use an array list in that particular case, we would be able to reduce the energy in that particular case. So that is exactly what we did. And let's go to the next slide. And we looked into a bunch of well-known software. There's Google JSON library, there's Apache Commons Math, there's K9 Mail, there's Apache Commons Configuration, etc. A bunch of software. And in different cases, because we were trying to tune stuff, we were sometimes making a good change in the code that is something that we expect to improve the performance. In other cases, we were intentionally making bad changes in the code. Like in case of Google JSON, we were making 51 bad changes where we were converting a collection class which was supposedly taking low energy into a collection class that was supposedly taking high energy. And what we have seen that actually reduced the energy consumption or increased the energy consumptions by about 3 times. Whereas on the other hand, if we did some good change, as is done in the last software in the pack, in that case, we were able to improve the energy consumption by about 38%. So what this does is we can essentially look at a tool that can not only modify your code in order to make sure that you will be able to consume less energy, and therefore like for example, if it's a mobile app, it's not going to drain out your mobile app, which is going to be a pretty cool feature to have. But these are also challenges that are emerging challenges that existing bug detection tools have no clue of how to even detect or fix. So as I've identified all of these problems, now let's talk about the solution. Let's go to the next slide. So our company, Open Refactory, is based on the principle that we fix code automatically. And Open Refactory brings in a technology that automatically fixes security, reliability, and compliance problems in software. Next slide. And what is also something to be proud of is Open Refactory is entirely developed by, so our entire R&D team is based in Bangladesh. So it is developed conceived by people from Bangladesh, myself, and actually implemented by our R&D team, which is located in Dhaka. Next slide. And what we have done is we have created a product called Intelligent Code Repair, or ICR. And that ICR is based on 3 key technologies. We do deep static analysis. That's where we create the mathematical model, and we actually consider all the roads and consider whether they were taken or not taken. That's the first problem, remember. And that deep static analysis allows us to be very precise. We also use machine learning and also use code refactoring technologies in order to build fixes for the problems that we find, so that the developers not only see that a bug is detected, but oftentimes they will also see that a solution is also found in that particular case. Next slide. So what this does is it improves the mean time to repair bugs. And we can do that because we are highly precise. Remember, we can go to the next slide. Remember that magic quadrant that I've shown at the start, that all of the existing bug detection tools, they typically have very low precision, and therefore the developers lose a lot of time in triaging the actual bugs. And they also, because they do not produce fixes, they also produce a lot of, the developers have to actually manually produce the fixes. Because of that, these tools do not, the overall experience of these tools is not very good. Whereas Open Refactory's Intelligent Code Repair, we are highly precise. On benchmark, we had less than 3% false positive, which means that every 20 bugs that we identified, perhaps one of them is a false positive. So imagine using that tool, and we will only be able to detect real bugs for you, and then people will be able to, and at the same time, we'll be also generating fixes. So that will reduce the mean time to repair bugs for you. Open Refactory is accessible, next slide, in 2 ways. It is accessible from the cloud. You can right now go to Amazon's EC2 Cloud Marketplace and be able to instantiate Open Refactory and use it as a pay-as-you-go mechanism. So you just pay for the hours that you use. You just connect to wherever your software is. If it is on a GitHub repository or a GitLab or a Bitbucket, which are the major source code management systems right now. And also, you can also scan code that is local in that particular machine, and you are just paying for the hour that you are using that. So it's just like a mobile phone. You pay as you go, and that's that. But sometimes you may need protection in the code. You may not trust your code to be in Amazon Marketplace. So for that, we also do cloud deployment. Next slide. We also do on-prem deployment. So in that particular case, our solution is available on your server, and basically it is connected with your automation server like Jenkins or Travis CI or GitHub Actions, etc. And basically our analysis engine, it connects with these automation server. It identifies where your source code is. It scans the code. It produces the fixes, and then you use the reviewer feature in order to review these the bugs that we generate. So that's typically you do that, and you so this allows you to have to be able to run refactory, Open Refactory's Intelligent Code Repair at your own home, or at your own workplace or inside your own firewall, so that your code is entirely protected. Nothing is shared to Open Refactory or any of the language or any of the features. So finally, we go to the last slide. This is basically a roadmap of where we are and where we want to be. Right now, we provide support. I see that there is a question about the language support. Right now, we provide support for Java and C. We are starting to work on Python, and at the end of the year, we'll also have support for Python. We will we are right now also have integrated the basic ideas of that framework problem that I have identified. So Open Refactory is right now able to understand some of the frameworks, and by the third quarter of this year, so around July, August, September, we will be able to support all the major frameworks like Java EE, Spring, Spring Boot, and Android. And at the end of the year, we will also be able to introduce Python. We will also be working on exciting new features like that particular problem that I've identified or shared with you about reducing the energy of Android applications. These features will also be rolled out as we go ahead. So I would be welcoming you to try Open Refactory, and I can assure you that all the problems that we have had in today's presentation, actually setting up Open Refactories from the cloud framework, we take pride that it takes less than 10 minutes in order for you to set things up and start an analysis. I'm pretty sure that we would be able to generate value for you when you see the results. As in, we will generate very low false positive. So we will be not wasting your time at all. Developer time is precious, and Open Refactory values that. So the future is fixing, and the future is intelligent code repair. I didn't feel like I would be able to come here, but I am happy to take questions. I see that there is a question about a trial offering. There is a trial offering. On the Amazon marketplace, there is a 7-day free trial. You obviously have to pay Amazon. Amazon doesn't give you free trial for its machine, so you'll have to pay about 40 cents per hour in order to use it. But that's something that we cannot really avoid. However, we do not charge anything for the first 7 days. For the local deployment, you can connect with our team, sales@openrefactory.com or info@openrefactory.com, and we will be able to generate a 7-day or 15-day free license for you for the local deployment. And in that particular case, it will be entirely free for you for 7 or 15 days in order for you to try it. Thank you.
If I could just add to that, a typical smaller project, by smaller project, say 100,000 lines or smaller, people may want to know how long that takes. Like if you're going to pay for hours, how many hours? It's a relatively short amount of time to do a 100,000 line program, well under an hour, just so you know. Larger programs, even 1 million lines of code, will probably take a few hours. So that just gives you an idea of how long you would expect an analysis to take.
We have another question, which is, does it run in Amazon T2 micro instance?
It does not run on T2 micro instance. I think the intent of this question is T2 micro instances are typically free. This is very computationally expensive. As I said, like most of, so there was an image, I was not there. There was an image about Sherlock Holmes and Watson. The point of that is that Open Refactory is very thorough. So when typically like in Sherlock Holmes stories, there is this comical scenarios where Holmes asks Watson to analyze a particular or basically do some intuition and try to make some guesses about some like criminal or something. And what happens is in that particular case, Watson typically does a quick scan and makes a lot of mistakes, whereas Holmes is thorough, and therefore he does not make mistakes. We are like Sherlock Holmes. So we are very thorough. We require computational power. So the minimum workload that we have are actually on a large machine with about 16 CPUs or 16 virtual CPUs. So that's why it's not available in a T2 micro instance. Right now it's only available under one configuration that we recommend that can support the power that we need for the computation.
All right. Thanks, Manur Hafiz, for your wonderful presentation. Hopefully, our audience will be benefited from this, discussion. And although we are really sorry that we went through some hiccups because of internet problems, but in the end, I think the discussion that we had is really it's really useful, and I'm sure would be beneficial for our audience. And now is your time to ask some questions, and I know we are already over the time. If there are any questions you have, let's take a few, and then since
As we wait for questions, I mean, let me just apologize for this thing. Here, let me explain this. I explained it. I'm not sure whether it got through. I mean, I actually came to Bangladesh 2 days ago, and right now I'm self-quarantining. So I am in a vacant house, and I practically do not know where the Wi-Fi connection is, or where the Wi-Fi router is, or how to reset it. And frankly, the Wi-Fi did not just work for me. So I was in a problem that otherwise would not have happened if I were doing it in a more familiar setup. But it is what it is. So that's we just have to bear through that. Sorry about this.
all right. So it happens. I mean, it's a part of life. So nothing to be. That's all right, I guess. I mean, I hope our audience will understand that it happens. All of them are part of life, right? I mean, we are in a pandemic situation. This is not something we wanted, right? But still, we're on on it. So yeah, hopefully, our audience will understand, and they will. Yeah. So that's all. I guess let's wait for a few questions, and if not, then we're gonna close it, because we are already over our time. Let's see. I know you were still watching, so let me throw some questions, and then we'll say goodbye for today. Hopefully. And I immensely thank you for your times and sharing this idea with our community. Hopeful, that's definitely you were doing great works. All right, thank you, Muhammad Rakib. Yeah. All right. I guess if there is no more questions, we can close this session. So thank you, Manur Bhai, thank you, Charlie, for your time. And I know we had Mustafiq Bhai as well in this session, but so thank you for your time to share your wonderful work with our community. Hopefully, people heard. I mean, they will definitely reach out to you if they want to get some benefits from your work, and that's all. Thank you very much, everyone. And Munir Bhai, any parting thoughts?
No, I mean, again, like, I apologize for the issues, but it has been a great opportunity. I actually welcome you to try this tool. There is a question a question or comment that I see right now. It's about like getting insights on how developers can write better codes. I mean, so essentially, like, the tools we have looked, or I've done some research work on, and basically the idea was whether this like having these kind of solutions available to the developer would allow them to or have a pedagogical effect, and have them be able to understand and appreciate what is the right way of doing codes. In general, like people will have to follow the guidelines, etc. What some tool like intelligent code repair, what it does for you is, wherever you are veering from the normal path of writing code, it is taking you back to the right path. So as you are using tools like this, which correct your code, you will be starting to learn. And after a particular point, you'll be starting to make patterns by yourself. As in, this is a particular mistake that I have been making again and again. and this is the tool fixing that particular problem, and that's the particular fix. So next time I write the code, I will not make that particular mistake. So these kind of tools like intelligent code repair may have a pedagogical effect if used in the long run. That's something that that the human-computer interaction researchers have also identified.
All right. That's a great great side effect, I would say. Yeah, tool sometime will teach us to be good at our things. All right. So thanks, Manoj, again for your all the wonderful thoughts and ideas you just shared with us, and the community will definitely be benefited from your from this discussion. So thank you, everyone. We'll hopefully join another session sometime soon from the JAG BD. We try to keep this frequent, but life happens. We get busy and other things, and we're going through a pandemic. So those are the reasons. Otherwise, we'll definitely we'll definitely entertain some more sessions in future. And that's all. Thanks. Oh, I see someone over here.
আমাকে একজন বললেন যে বাংলায় একটা ইয়ে করতে, যে আমি সবাইকে তো আমন্ত্রণ জানাচ্ছি যে আমাদের এই টুলটি ব্যবহার করার জন্য এবং দেখার জন্য যে বেসিক্যালি আমাদের মূল উদ্দেশ্য হচ্ছে ডেভেলপাররা যে সময় নষ্ট করে, ডেভেলপারের সময়টা হচ্ছে সবচেয়ে গুরুত্বপূর্ণ রিসোর্স। এই সময়টা যে নষ্ট করা হয়, আমরা বিভিন্ন ক্যালকুলেশন করে দেখা গেছে বা থিওরিটিক্যাল ক্যালকুলেশন করে দেখা গেছে যে potentially intelligent code repair, it can improve about 15% of developers' time. So it almost feels like যে আপনার টিমে যদি 5 জন ডেভেলপার থেকে থাকে, essentially if you use this tool in the long run or use this kind of tools in the long run, it will have an effect যে এটা হয়তো আপনার টিমে 5 জন ডেভেলপার নাই, as if আরো একজন এক্সট্রা ডেভেলপার এসে যোগ হয়েছে, 6 জন ডেভেলপার আপনার সাথে কাজ করছে। সো এই যে ডেভেলপারের সময়টা নষ্ট হলো, এই সময় নষ্টের সাথে প্রোডাক্টিভিটি জড়িত, এবং এই প্রোডাক্টিভিটির সাথেই আলটিমেটলি সফটওয়্যার যে ডেলিভারি করার টাইমে একটা হাই কোয়ালিটি কোড ডেলিভারি করার প্রয়োজন হয়, সেই নিডটা ফুলফিল করা সম্ভব হবে। এবং এইখানেই এই এখনকার ডিটেকশন টুলগুলো যতটা সম্ভব করছে, বাট সেটা এই ডিটেকশন টুলগুলো প্রায় 20 বছর আগে পুরনো টেকনোলজি। আমরা চাচ্ছি যে এই নতুন টেকনোলজির মাধ্যমে, অর্থাৎ যেখানে শুধু ডিটেকশন না, এই ফিক্সিং টুল, যেটা আপনার বাগ শুধুমাত্র ডিটেক্ট করবে না, এটাকে অটোমেটিক্যালি ফিক্সও করে দিবে, এই ধরনের একটা ফিক্সিং টুল আপনাকে এই মানে এই যে মানে অর্থাৎ এটা নেক্সট জেনারেশন টেকনোলজি, এবং এটা একটা নতুন ওয়েভ সূচনা করবে, যেটা লাইক ইন ফিউচার উইল বি ইউজ মোর অ্যান্ড মোর প্রমিনেন্ট। এটাই। ধন্যবাদ।
Okay, Charlie, do you want to say anything at the end?
No, I just decided to put my video on at the end. You can see why I decided not to do my video, because I'm having a problem with one of my eyes.
Oh, I see.
I have to wear a patch and it's distracting, so I didn't want to have my video on. All I wanted to say is thank you for your patience in dealing with the internet problem, and I apologize for not being as eloquent as Munawar in going through the presentation, but hopefully you got the ideas, and I was glad that Munawar was able to pick it up and so on. And also, I do see questions. I saw someone make a comment about there's lots of information here. Indeed, the case. So we're open. I'm very excited about the technology. I think there's some cool stuff here. So if you have questions, you want to know some more, feel free to drop us some emails, and we'll be happy to get back to you. Did we provide an email contact in the posting? I don't recall.
info@openrefactory.com, or that would be the, or just email me directly, munawar@openrefactory.com, and I'm typically very responsive about emails as well.
Yeah.
All right. So the email address is info@openrefactory.com and or monwar@openrefactory.com. So that's the email. So you have the email. If you have further query, feel free to reach out, Monwar and the or through the info@openrefactory.com. So hopefully we'll get your answer. Okay. All right. I think we don't have any more questions. So. That's all. Thank you guys for your time and wonderful talk again.
Thanks.
Bye-bye.